Hey guys, welcome back to my channel and I hope you all are doing good. Today we are going to solve another lead code problem, that is optimal partition of string. It's a medium level question. Let's read the question. Given a string S, partition the string into one or more substrings. Substrings means they are continuous sequence of characters within a string. So one or more substrings such that the characters in each substring are unique. That means the substring should comprise of non-repeated characters. And another possible partition is AB, A, CA, BA. That is, no letter appears in a single substring more than once. Return the minimum number of substrings in such a partition. Note that each character should belong to exactly one substring in a partition. Let's look at the examples. So we are given an input string S and there are multiple ways of getting such substrings. You can see the first one, there are two possible partitions. So A, BA, CAB, A. Each of these substrings, if you notice, they do not have any repeated character. So let's take this example to understand further. I have taken a variable substring which will store the valid characters. Okay, so the first character is A. A is a unique character. We have added it in our substring. And also I have initialized count as 1. Because there will be at least one substring from our given input string. Suppose our input string doesn't have any character repeated, so that string will itself become a substring. Fine. So we have initialized count as 1. So for every input string, there will be at least one substring. Let's move forward. Now comes B. Is B in our substring? No, it's not there. So I have added it in my substring. Let's look at the next character. It's A. Is A in our substring? Yes, it's there. So we can't add this character in our substring. It was mentioned in our question that each substring should have unique characters, right? So our goal is to extract the characters, keep on extracting the characters until you find any repeated character or any seen character in our substring. I need to put a partition. If I put a partition, then I have already got one substring. Now a new substring begins. Therefore, I have incremented count. So now we will empty our substring and start it again. And so now my pointer is at index 2. Is A in my substring? No, it wasn't there. So I have added it in my substring. Increment the index again. It's C. Was C in my substring? No, it wasn't there. I have added it in my substring. My count is still 2 because I didn't put a partition. Currently, I have two substrings. Let's move to the next character. It's A. Is there in our substring? We can't add this one. Again, we have to make a partition. So now we have three substrings. Okay, keep the count. We have three substrings. So we will clear the substring, add in our substring. Increment the index, it's B. Was B in our substring? No, it wasn't there. So we have added it in our substring. It's unique. Now increment the index, it's A. Is there in our substring? So we can't add it. Now I can add A in my substring and I have incremented my count as 4. So total there are 4 substrings. So we keep on iterating the string till any of the element is seen in our substring. Once you find the repeated element, then you simply increment the count and reset your substring. You can pause the video and look at this image. So the substrings which we have extracted are AB, AC, AB and A. The characters in each substring are unique. Let's check if our answer is correct. So you can see there are multiple ways of arranging these substrings. What they care is how many minimum number of substrings you have got. not the way you have reached it. They have given us a function called partition string in which they are passing the input string s, and the return type of this function is int. So I have initialized count as 1 and taken another variable substring in which I will be storing the characters. Running a loop, taken another variable result in which I will be storing whether a character in string s exists in substring or not. If the result is true, then it means that the character in string s exists in substring. We will increase the count, indicating that we have to start a new string and empty our substring variable. If the result is false, then we will let character in string s get added in our substring. When the iteration completes, we will return the count. Let's run the code. The given test cases have passed. Let's submit it. Solution is accepted. The next approach to solve this problem is using bit masking. But before diving into it, let me remind you how to find the position of the character in the input string relative to the character A in ASCII table. The ASCII value of H is 104. We have subtracted the ASCII value of A from 104. Similarly, I have demonstrated for the other characters. These positions will help us to map the characters. See here, all the positions corresponding to the characters are typed. Okay, now coming to our main point. What is our goal? Our goal is to store the frequency of the characters in the input string so as to keep a tab on whether the character is repeating or not. To achieve that, we will use bits. Bit is represented by 0. So for all the characters, initially I have taken flag as 0. Let's understand using an example. I've taken a string hello. Whenever I iterate over the string, the first letter is H, and you remember that we have found the positions for these characters. H is mapped by 7. So at position 7, I have set the bit. Now the next character is E. Set the bit for E. Then the next character will be L. Similarly, for this also I have set the bit. So setting the bit is helping us to keep a tab on the characters which are occurring. Now the next letter is L. See, L is already set. That means that L has occurred before. So what is the way to check whether our bit is set or not? We have mapped position for every character. So for L, it's 11. Therefore, we will left shift our 1 by 11. After left shifting it, when we use the AND operator with flag, we will obtain whether we have set the bit earlier or not. If the answer is 1, that means the character was earlier visited. With the help of the string, you have understood how we check whether a bit is set or not. In the next example, I will tell you the next step, what we will do if the bit is already set. See, the first character is A. Set A. Let's move. The next character is B. I've set the bit. Now, the next character is A. A is already visited. Since A is visited, we will set flag as 0. Now, starting afresh, the bit for A is set. Now, move to the next character. C is set. Now, the next character A. See, A is already visited. So, we will, the same thing we will do. We will now set the flag as 0. In a new substring, set the bit. Next character is B. We have set the bit for B. Next character is A. It's again visited. So that means there will be another substring. So we will set the flag as 0. Start a new substring. I will set the bit for A again. Remember that every time you set the flag as 0, you're starting a new substring. Let's look at the coding portion. So I've initialized count as 1 and set the flag as 0. I will be iterating over the given string, and here I am finding the position of the character in string S relative to the character A. It will indicate how many bits we have to shift so as to set the bit. In the next condition, we are checking whether the bit for a particular character is set or not. If it is, then we will reset our flag to 0 and increment the count. If the bit for a particular character is not set, then we will, in line number 13, we will set the bit. After the iteration gets completed, we will return the count of the substring. Let's run the code. The test cases have passed. Now let's submit it. Our solution is accepted.